Hi, in this video I will introduce continuous random variables. How are they different than the discrete ones, and the events we define, what are the best events we define using continuous random variables, and specifically how we compute the probability if a PDF function of the continuous random variable is given. Well, let me start with recalling that a random variable is discrete if it has only finite number of values. In other words, all the possible values it can get if you count it will end at some point. Also, when we were working with discrete random variable, then one of the important events was like, okay, what is the event that x gets a number like xi? Yes. Then we found the probability of such a thing. We called it PDF of that random variable at that point. So which was abbreviation for the probability distribution function. But while we have to consider more general random variables, the random variables which definitely have more than finite, and also we are looking for very specific random variables. We call them uh, continuous random variable. X is a continuous random variable if the set you put all the possible values for this random variable, it's not only just finite, not only that, but also it forms a range of numbers. So if the possible values of x form an interval. Interval means a range. Interval on real numbers. So this is the definition your book will use for the continuous one. So we are not working in general cases, but when the possible values you put all of them, it will give you a range rather than just bunch of numbers or discrete number of things. What it will give you a range, an interval, then we call that random variable discrete. No, sorry, continuous random variable. Examples of such random variable. Well, let me just write two examples at least. For example, any random variable which takes time of some process, some work, some job. So random variable which gives you the time length of a trip from London to Toronto. So when it comes to to time, it's not just bunch of numbers. The time can be anything in a range, like in a range, say between half an hour or say up to 10 hours. And this time can be any number between these two. Yes. Or a random variable which measures say the height of student, the height of students at Brescia, let's say. So such a random variable, well, it can give you any number. So possible values will be a range rather than just discrete numbers, and that's another example of continuous random variable. Something that you have to note at this stage is that, well, when you work with random variable which has a continuous range, then probability of if x is continuous, the probability of that x being equal any single number, there are all the possibilities are the total range, some interval. The probability that x is going to be one of these number in this range is so small, basically is always equal to 0. So if x is continuous, this will happen. Well, this should ring a warning bell in our mind that, well, what then what we are going to do? This is the starting point. This was a starting point for us to study the discrete random variables. You see, the PDF was defined using such events, but here, when it is continuous, the probability of such events are 0. What should we do? Well, when it comes to continuous random variables, um, uh, the interesting, sorry, let me go back to the black. The interesting events are the ones defined by inequalities such as x between two numbers, or x less than a number, well, less than, equal, or less than, or probability of x being bigger than a number. So these are the events which are more interesting in this case. And then, the PDF for the discrete, for the continuous one, is defined this way, okay? The probability density function, well, again, PDF before was probability distribution function, now it is PDF, probability density function. Again, we call it PDF, of a continuous random variable x is a function which is non-negative, meaning that, well, this thing is going to deal with probability, we only take the positive, and it somehow gives probability of events of this form. Probability of x between a and b is given by the area of the region under the graph of f, and above x-axis on the interval a, b. In other words, if the function, which is positive, means that just leaves off there, if you're looking for probability of AB, what you need to do is to find the region bounded by the graph of the function and the x-axis on the interval AB. Find the area of that is equal to the probability. And you see right away that this is a big difference between continuous and discrete random variables. In the discrete one, you have PDF, which gives you probability of x being equal one of these guys, but when it is continuous, we are going to deal with the area under the graph on that interval. Well, I have two remarks to add here. One is that remark one, let me just write. One is that, well, you see, now we can see why probability of x being equal to a number, which is the same thing as x being bigger than equal to that number and less than equal to that number, is 0, because if you look at the graph, the region under the graph of the function from A to A, there is no two-dimensional region there, so the area is 0. So that's why. And as a result, as very important, so as a result, unlike the discrete random variables, when you're trying to do, for example, probability of x being less than equal to A, the probability of such a thing is same thing as probability of x being less than A and probability of x being equal to A. But this part is 0, so you see that probability of x less than equal to A is the same thing as the probability of x being strictly less than A. And similarly, you have probability of x being between A and B is the same thing as probability of x being strictly bigger than A and B, or it is the same thing as x is strictly less than B and bigger than equal to A, and it is same thing as this. So in the inequalities, when it comes to continuous random variables, the inequalities that define the good events for us, including equality or not, doesn't change the probability. That's the first thing. And then remark two is that, as always, the probability of x, all the possible values of x, probability of all values of x, in other words, probability of x being between negative infinity and plus infinity, it needs to be equal to 1. We know that the total probability is always equal to 1. In other words, the total area of the region under the graph of PDFF is equal to 1. So this is also another condition, another thing that we will see and we will use. Just very quick review. When it comes to the continuous random variables, we are dealing with random variables whose values form a range rather than just discrete points. The good events are defined by inequalities, and then PDF, probability density function of a continuous random variable, is a function which is non-negative and gives us the probability by the area of regions under its graph. Then we have these two probabilities. When it comes to continuous random variable, equality doesn't doesn't matter, it's always zero, and if you drop equality in an inequality, it's not going to change the probability. And the last thing is, as always, probability of the total probability is always equal to